So without further ado, I would invite Josh Reed on the stage. Yeah, right there. He's a senior engineer in test release at Haven.io. He spent 5 years of his career working to help teams achieve efficiency and quality in the development process. His motto is ship better software faster, and he's here to talk about software delivery from the first principles.
In fact, you can, if you don't want to leave now because there's nothing new, you can go ahead. It's fine. But we're going to, what I really want to do, because when we bring a lot of people from different companies, different walks of life, different experiences, we find out sometimes we actually have slightly different ideas of what we mean when we say the things we say, when we use the words we use. And that's why I want to talk about metaphors, because everything we do is kind of built out of metaphor. And if you don't believe me, just think about the word software or software delivery. Those are both metaphors. Like software is a metaphor. We're talking about building machines out of ideas. We reached to this thing. We said, oh, well, we have glassware, we have silverware, we have hardware. Well, why not have software? That makes sense. It's just the opposite of a hammer. And even in French, it's the same thing. Logiciel, c'est un matériel logique, pas un matériel physique. It's a metaphor for what we're talking about. And so we want to go deeper into what these metaphors mean if we want to understand them better. How do metaphors work? Well, we discover a new concept. We're thinking about something, and I have this thing. It feels pretty thingy, but I want to talk about it more. I want to be able to talk about this thing as opposed to other nebulous set of ideas. I want to be able to discuss it, so I need to name it. And when we name it, we just reach for something else that we know, something usually a bit more concrete. And then we take all those traits, those ideas, the associations of whatever other idea, and we apply it to the new thing, and now it makes sense. A good example of this might be something like the word head. When we talk about someone being the head of an organization or the head of an operation, we don't literally mean that they are, a giant head and nothing else. We understand that the head leads the body, and so we take that notion of leadership that we ascribe to the head, and we apply it to a person pretty easily. With words like that, it's so common that we barely even notice it's a metaphor anymore. It's just normal language. When we do this in specific communities, it becomes jargon. But when you do this, more widely within a language community, it's just language. Metaphors can be useful or they can be distracting. Another body metaphor that we might use is muscle. You talk about someone being, the muscle behind something that keeps. We have an idea of what that means, especially in the context of, a crime gang. But if we were to use that to talk about someone being the muscle of a software team, that would be a bit distracting and confusing because we still have this really physical connotation of muscle. The traits and associations and images we have of a muscle is something very, very, very physical. And so when you apply that to software, it doesn't make sense. We might not know what you mean. It might be useful in some cases, but we need to be careful about that. So in that vein, when we talk about delivery, I want to talk about what images come to mind when we talk about software delivery, and that's the word I want to use today for this process. There's last leg delivery, like Amazon. That might be something we're really familiar with. You might think of pizza delivery, especially if you're hungry. If parcel shipping is another thing that might not quite be maybe a bit more broad than delivery, but it's still delivery. And going even more abstract and a little bit wilder, we might think about global shipping and distribution. These are varying degrees of usefulness. I think that last leg delivery is something that we should definitely be thinking about automating. We shouldn't think about us being the delivery driver. That's a terrible metaphor for what we do. Unless there's somebody out here that's still physically taking their software to the customer. Is anybody physically taking your software to the customer? Okay, no. If you are and you're ashamed of it, it's okay. Just come talk to me afterwards. I want to know more. Pizza delivery is a really interesting one, even though we don't want to think of ourselves necessarily as a pizza delivery driver. I did that when I was 16. It was a great job then, but that's not what we want to talk about. It's interesting, though, because the delivery affects the product. Does anybody here like Neapolitan-style pizza? Like, it's good, right? It sucks delivered, I find. Like, when you get it, it's soggy, it's cold, it's awful. North American kind of style, pizza pies they have a thick layer of molten cheese. They got a decent-sized crust, a lot of sauce that actually stays warm through the whole process. And it seems like this fact that we deliver pizza has affected how the form of our pizza. And you might disagree whether that's better or worse, but it definitely has affected it. That's a really key insight, though, that we can apply to how we think about software delivery, is the fact that we want to ship it at a certain rate or in a certain way should affect how we design it. I don't want to talk about parcel delivery services. To me, the best analogy of that in software is like a distribution channel, like a CDN or an app store. Those are interesting topics, but they're not for this talk. Global shipping and logistics is really interesting because the logistical problems dominate, which is really what brings us to the next point, which is that software is industrial. The software DevOps stuff is really industrial engineering. This insight came to me recently that I know so many good software developers that are terrible at DevOps and just don't get it. And I keep wondering how can you be so good at this and so terrible at that? And it's because it's not software engineering. It's not literally building software or literally designing software. It is designing systems and processes that produce good software, which is a lot more akin to industrial engineering. I don't even know if this is the right meme for this concept. If you have a better meme, come talk to me afterwards. I'll replace it. But a more succinct definition for this, that if you need to quote somebody on it, might be getting software features from developers to end users while minimizing defects. That's a nice short dictionary definition. If you need to impress business people, we might say building repeatable processes for delivering value from investments in technology. I like that delivering value bit right now. That's kind of a buzzword in business it's not really a metaphor, it's just a shorthand for something that pays off somehow. And that's one of the reasons I'm sticking to the word software delivery, is because it echoes that and might get us some more funding to do what we need to do. What we'll talk about today specifically as the building blocks of this process. Builds is a fundamental idea in the manufacturing of software and how we actually construct it somehow. Pipelines is the other big metaphor we have going on that really is analogous to the intershipment or the different points at which a manufactured good might get from one place to another, and the feedback, which is critical to making this all work. We'll start with builds, and builds is fundamentally a kind of a blueprint and construction metaphor. We have a recipe for software. We have a recipe that we know how it's supposed to happen, and we need some way to transform that into another form. This, of course, classically applies to compiled languages and how we orchestrate all that, but it can also be thought to apply to things like Python or Ruby or JavaScript or whatever else, because you tend to package those up in some way and you transform them before you write them. So we have this notion of, I have this blueprint of software, it needs to go somewhere else. That's the fundamental idea of a build. But because of its properties, this can become really, really abstract and take on a lot of different confusing definitions. The classical one is to orchestrate compilation. This is your make files or whatever other tool that has to do, compile lots of different things together and possibly link them depending on what you want to accomplish. Has recipes for doing that. We might extend this to just generically performing development tasks. And I think this is probably the most common way this term gets used within the DevOps community, is just anything that involves performing development tasks or doing that on a local machine or in CI. So that includes things like linting, tests, etc. We can also use it to refer to specific instances or runs of this, especially in the context of CI. Oh, did you see that build 172 didn't pass? What do we need to do there? And then if you're really a hardcore build nerd, any directed acyclic graph-based task execution can be considered a build. Again, if you know people that talk like that, then you might stay a little away from them. They're weird. I'm one of them. Just to demonstrate what I mean by a directed acyclic graph, or a DAG, this is a classic kind of C makefile type thing where you have an executable hello that depends on an object file, which depends on a source file and a header. And that graph is a graph of dependencies. The fact that it's directed and acyclic means that we can sort it topologically, which is an important thing for for the build system to understand how to execute things in the correct order, because it just has to reverse these arrows, and it can create these generations of what it needs to run things in. Make has a rudimentary system for avoiding rework, where it can go back and look at the modification time of the inputs and see if the inputs are newer than the outputs. And then it has this clunky mechanism called phony for saying this is not actually, it doesn't actually involve a file, it's just a task I want you to run, which is obviously how we kind of expanded this term into just being a generic task runner. Tasks are things that have dependencies. We have ways of avoiding rework, like make has mtime, but fingerprints and hashes, checksums, things like that are a lot more robust, but they come with their own trade-offs. If you want to, you can have arbitrary kinds of checks for this kinds of thing. Reproducibility in builds is another key idea that allows us to avoid rework, kind of paradoxically, because you think reproducibility, I can redo it, but reproducibility, the lack of reproducibility is what makes you do things like run git clean or make clean before your build, because you don't trust that your build is actually very reproducible. You don't trust that you understand the inputs actually produce the outputs that you want. So you end up doing more work because your build is not deeply reproducible. It allows you to trust your caches and trust the previous results of your outputs when you understand what reproducibility is. This requires a level of determinism that most of the time we're not really willing to go into, because it's unusual for us. It takes a lot of effort to get there. There are some build systems that try to force you into this in a deep way. And also, at some point, there's diminishing returns. It's one thing to know all the inputs of your build, but it's another thing to try to eliminate, you wouldn't think that file system metadata like the modification times of files or the usernames of the owners would impact the result of a build. But if you run tar on something, then all of a sudden that gets included in the bits that are in your output. If you want to know more about this, there's actually a really good article about how they did this for the Go compiler and made it completely reproducible, and just how much work that goes into that. So maybe in some cases that's really worth it, but getting 100% reproducibility is actually very difficult, and sometimes we have to apply the 80-20 rule to that. We have ways of dealing with that. I'll go through a few examples of what build systems are. Here, we all know Makefile, it's the classic. Redo is a more academic, interesting idea out of that. I think it's interesting to look at if you have some time. If you're into the whole task running thing, there are newer tools out there like Just or Task, which are actually handle that notion of task running much better than Makefiles do. If you just want to have an easy way, a convenient way to run tasks in your repo, those are great things. You should check them out. People who do C++ and more complicated development came up with something CMake and Meson and things like that, which are so complicated that they actually generate make files. So they call themselves meta build systems, but it's the same concept. New trend is also to have language-specific build systems, like Cargo for Rust is a well-known one, or the Go compiler itself has one built into its compiler that can handle the orchestration of builds. Packaging tools are build systems. In a sense, we don't really compiler-oriented, but they do produce artifacts that we end up using later, and that really is the RPM logo, as far as I can tell. Isolating build systems are among these kind of, I don't know what the right term for this category is, but these are systems that try to aim at having perfect reproducibility. Bazel and Pants are tools mainly for monorepos. Nix and GUIX are tools for packaging systems. These tend to be super, super intense about making sure that your builds are absolutely 100% reproducible. And if you want to find out what the trade-offs are, try using Nix. I like Nix, it's really cool, but it's also a really, really confusing and different and can be challenging to work with, just because it's so different than what we expect. Same with Bazel and Pants, which I work with Pants too, and it can be quite difficult. But they're very powerful because of that, because you can just run the same thing over and over, and it will never do more work than it needs to. Another example of a build system is Microsoft Excel, which you might not think of as a build system, but there's a really great paper out there about why it is. It's called Build Systems a la carte. Yeah, people are looking confused in here, like, what am I talking about? No, but think about it. Microsoft Excel, if you have a formula that depends on a formula, and you change one of those values, then it'll recalculate all of those things. Like, it functions like a build system, it just doesn't build software typically. But again, like, I recommend looking at that paper if you're interested in any of those things. Really interesting stuff. Pipelines are the intershipment, the intermodal kind of shipment we have within our system. This is the steps to perform to get somewhere for delivery. The metaphor invoked here is one of bulk flow. I can't shake the idea of this being like a sewer or maybe Super Mario metaphor. So I always find it kind of a weird thing that we call it, but I also don't have another name for it, and it's really well established. But the idea here is really about optimizing flow. And if you know anything about real pipelines, about gas pipelines, or things that focus on delivering materials over a long distance, they're actually way more complicated than a sewer pipe or the pipes in your house. They have all kinds of technology involved, inspection points, monitoring, the whole deal in a way that's meaningfully analogous to what we do. And I think the glove fits a little better when you think about it a bit harder. Like, you think about this idea of a pipeline transmitting something huge over a long distance. Well, of course, if you have a leak at one point, you need to know about that really immediately. In the same way that if you have a build failing deep within your pipeline, you need to know about it immediately so you can react to it. An important part of pipelines are gates. Again, another metaphor that I found really confusing because I was like, where's this coming from? Until I realized it came from logical gates. And we're basically just saying it's an AND gate at every point along your pipeline. This must pass, and this must pass, and this must pass, and this must pass. These are the ways you control the flow of your pipeline. I like the word gates as opposed to checks or tests because it's more generic. It can include things like you can talk about having merge gates, that prevent you from having merge, and that can include a number of things. And you can talk about having bureaucratic review gates, like PR processes, or if you have some kind of a more organized meeting or some sort of compliance oriented things, those can be a gate. Your smoke test later on before deployment can be a gate. Any number of things can be a gate. You can have gates that allow you to progress from one canary rollout stage to another. It's a much more generic idea that you can apply than just saying test, and I think that's the word I like to use for these kinds of things. In a CI/CD pipeline, each node is a gate. It's a point in which we can stop, analyze, and think about what we're doing. It's a point in which we can program to realize, something's going wrong, we have an issue. The things that we're moving through the pipeline are artifacts. They're what is produced by a build. The metaphor invoked is made from labor. That's the literal etymological definition, is made from human labor, which is kind of weird because the computer did it. But the other jargon you might end up with here are things like binaries or targets. Usually people that are deep in compilers or build systems might use those things. The ordinary word I think we use is artifact. Artifacts are great because they can make up for that lack of perfect reproducibility. Because you can know where an artifact came from and who built it and why and when, and you can say that I have the same artifact in one point of my pipeline moving to the next, you can trust that it's the same thing, even if your reproducibility is only 99% perfect, because we have provenance on that. And you can do things like sign it, which starts to turn it into a package, which is just a special kind of artifact that exists in a specific format for a specific platform. The metaphor invoked is shipping, and like all things that get shipped, there's manifest, there's information about what we're shipping that allow us to reason about what's in the box without actually opening it up. And that's a really powerful metaphor that we can leverage to move things along. I've written several ad hoc packaging formats in my life, and by ad hoc packaging formats, I mean it's a tar file that I stuffed a JSON file next to just because I need some part of my system to understand what's happening. That to me is a package. I don't necessarily want to build a Python wheel or a Debian package or whatever for every single step along my pipeline, but it can be useful to tag it with some metadata. We keep packages in repositories. We keep artifacts just in general in repositories. The metaphor is storage. Repository is essentially a synonym for warehouse. Like warehouses, the semantics or the location of where you put things is contextual. And so if you might keep different repositories or use different metadata to express different purposes for your artifacts. You might say, I'm keeping this artifact here because it's for dev only. This one's been promoted to staging. This one's been promoted to prod or going out to different environments and things. We have different ways of expressing that. You can view them as a blessed cache if you want to. In fact, again, Systems like Nix or those really anal about reproducing systems do view them as blessed caches. In fact, Nix packages is just a cache in their view. But for the rest of us, repositories are a really useful way to say, these are the artifacts that I care about. These are the ones that I trust and we know and we can talk about. Deployment is the final bit of it. A real close synonym is just release. We use deployment more now because more of us are doing software as a service, I think. And I think that's why we use that term. Used to when you put software in a box, that would be a release. Deployment can still include tests. I mentioned smoke tests before for deployment. You can do post-production tests. I don't know who's doing. Does anyone do tests after release here? Okay, we got some hands. Acceptance tests or ongoing testing. That's cool. The metaphor is fundamentally military. I don't think there's a whole lot to derive from the metaphor here. Deployment literally means just putting your troops out on a line. I think we just borrow that concept, and there's not a whole lot to gain from that. It's also something that's ripe for automation. Like I said before, if you're not automating every element of your deployment, we're not trying to be the delivery drivers here. We're trying to be the people the engineers that design the process that make this happen. And lastly, I want to talk about feedback. Pipelines are not just a one-way thing. I think one of the reasons I struggled with that metaphor is because I thought pipelines are unidirectional, and everything I want in software, we need to make sure we have feedback all the time. But in reality, even the simple, dumb pipeline, it has things going both directions. Pressure is information going backwards towards the beginning of it. And if you don't deal with pressure in an early, meaningful way, you get clogs, and you get pipelines that run really slow. So having timely, relevant feedback is critical. The feedback can be about the code, about the artifacts that are actually going through the pipeline, what's wrong with them, or the feedback can be about the process itself. Is the infrastructure of the pipeline bad, or is something about how you designed your system or designed your gates not functioning in the way it should be? The gates themselves are feedback. So things like continuous integration gates let you question the value of the commit. And if you set certain goals on what time and what you aim to actually achieve out of that, you can design your pipeline accordingly, and then that itself becomes a set of feedback about that. Your code review is a gate and is an important feedback element that you can also optimize. Post-merge things, things moving into staging or into canary, whatever you're doing there, is feedback about the quality of your merge. And the whole thing ends up being feedback about like later feedback stages are feedback about earlier feedback stages. What did I miss earlier? What easy, faster test did I not run that I was supposed to run that would have caught this, that would have been cheaper and would have been better? What am I missing? And so understanding that it's not just about like, oh, this code, failed the test here. It's what tests are missing, what gates are missing, what process didn't allow me to see this earlier. And this goes back into observability, which is, we can have the conversation about whether observability is just spicy monitoring, probably, but changing the idea from just monitoring from a metaphor of, a watch person, watching over things to we need to see into a system is useful in and of itself because I think it's more dev-centric. It enables the ideas of devs need to have this kind of feedback and need to be able to understand this feedback about these complex running systems very, very rapidly. When we talk about monitoring, I get the idea of, I had a colleague that used to have 7 or 8 monitors, and they just have Grafana all over all of them and just watch things. And I don't think that's a particularly useful way to think about observability or think about how we should be doing things in the modern age. It's about timely, relevant information getting to our users. Observability obviously merits its own talk, and I won't go too much into it here. But to summarize all this, the specifics of your pipeline, your builds, your feedback scenarios, your organization are going to vary dramatically. But if you know what your goals are and what you want to accomplish, you can use these ideas as brick material to build up systems, to analyze problems, and to solve things and to make changes and improve your pipeline. That's all I got right now. You can, the top left is my contact information, and then the bottom right is about Ivan, my company. If you're interested in focusing more on these kinds of pipeline problems and optimizing your delivery, and less on hand managing databases and other data service deployments and backups and things like that. Check us out. We can help you out with that. Any questions? Est-ce qu'il y a des questions? Thank you.
Nice. Thank you very much, Josh.